Hi, today I'm going to show you how to work a critical path method, a CPM network, forward and backward. We start the project. This is from problem 12 in your book. We have 3, 6, 7 activities. Time for each activity is indicated. These are in days. I'm going to make a key. On top of each node, I'm going to put early start, early finish time, and we are going to calculate these times going forward in our network. Then coming backward in our network, I'm going to calculate latest start and latest finish times. The time for each activity is indicated inside the node. Activities A, B, and C are all starting activities for the project. So the earliest time that they can be started is time period 0. So that's the early start for them. But activity A takes 2 days, so 0 plus 2 is 2. That's the earliest time that we can finish A. 0 plus 1 is 1. That's the earliest time that we can finish C. And 0 plus 5 is 5. That's the earliest time that we can finish B. Now, I'm going to put the verb can and must next to these times. Going forward, earliest start and earliest finish times are times that the earliest time and earliest finish that we can start and finish an activity. And in our backward pass, these are the latest start and latest times that we must finish the activity. For activity F, C must be done before F can begin. So the earliest start time for F is the earliest finish time for C. So I'll put 1 here. 1 plus 6 is 7. E has 2 preceding activities. Both A and D must be done before E can begin. So we must do the computation for D first. 5 from here becomes the earliest start time for it, plus 10 is 15. Now, since both A and D must be done before E can begin, the earliest start time for E is the largest of the two, which is 15, plus 3 is 18. Notice in our forward pass, when we have more than one number to choose from, you pick the highest. So in our forward pass, you pick the higher value. And finally for G, the choice is between 7 and 18. I'll put 18 here. 18 plus 8 is 26. And now we can interpret this 26 to be that this project can be done at the earliest time that it can be finished is in day 26 or in 26 days. Now, for our backward pass, let's go ahead and use that 26 and set it equal to our latest finish time. So I'll put 26 here. So we're saying G must be done in 26 days if the project is to be done in 26 days. So earliest finish time that we can finish it and the earliest time that we must finish it are set equal to each other. Now subtract 8 from it and you get 18. Now this 18 becomes the latest finish time for E. Carrying it backward, 18 minus 3 is 15. This 18 also is used for F. Subtract 6 from it, you get 12. Now, backtrack this arrow. The 12 becomes the latest finish for C. 12 minus 1 is 11. Backtrack this arrow from E to D. This 15 comes here, minus 10. Gives you 5. 5 minus 5 is 0. And for this one, backtrack the 15. Minus 2 is 13. So now we have solved the network forward and backward. For each activity now we can calculate slack. Slack for each activity is also called float, and it can be computed 2 ways. you can either take LF minus EF. Another way is LS minus ES. Either computation should give you the same answer. I suggest for each activity, do both computations quickly to make sure. The reason is that if you made an error going forward or backward in your calculation, then these two numbers would not be equal. So you want to make sure that you calculate slack both ways. Now, 15 minus 2 is 13. 13 minus 0 is 13. So here's slack here. Here. Oops. So we can see that the activities that have 0 slack are activities B, D, E, and G. These are the critical activities. I can show the critical path by highlighting that path. And notice that time for B is 5, for D is 10, for E is 3, and for G is 8, which adds up to the 26, which is what we computed. So the critical path is the longest path through the network, and it's the least amount of time that we can do the project in, or we need at least 26 days to finish this project. Notice that all the other paths are shorter than 26. For example, CFG is 1 plus 6 is 7 plus 8 is 15. Still 26 is longer. Or AEG is 2 plus 3 is 5 plus 8 is 13. So still our critical path is longer. So the critical path is defined to be the longest path through the network, and it tells us the shortest time or the minimum amount of time that the project can be conducted in. And that concludes our session on critical path method.